Okay, good morning, Year 12 MAC. Today I'm going to show you how to find the equations of the exponential graphs on page 14 in your booklets. Okay, I did ask you to try and do this. I don't know how many of you naughty boys have managed to do it. Anyway, let's see. What I've gone and done is I've separated all the graphs I, J, K, and L separately because to try and show you how to find their equations all on the one graph as it's written, as they've been shown in the booklet, would get a little bit complicated. So I've done each one separately. Okay, let's look at the first one, graph I. Here it is here. Well, graph I, you will have seen, is something like this. Okay, the very first thing you should home in on is the fact that there is an asymptote here. See that dotted line there? There's the asymptote at y equals 2. Very important feature of the graph. And again, we are looking to see where does this point here, 0, 1, which is see this red dotted line, red dotted curve here. This is the sort of like original exponential. Where has this point on the original exponential gone to in our new exponential there? Well, just as this point here on the original exponential is 1 unit above the x-axis. The x-axis here, by the way, is the asymptote for this original exponential curve there, but it is 1 unit above the asymptote. And the same has to be true for our new exponential there. We're looking for the point that is 1 unit above the new asymptote, and there it is there. This is the new asymptote there. So from 2 to 3, okay, go along there. That must be 1 unit above the asymptote of y equals 2. Okay, so that is a very important point to actually find. Okay, where has that point gone to in the new exponential? Well, it's there. Well, how did it get there? Well, obviously the original exponential must have gone 2 units up from 1 to 3, and then 2 units that way to minus 2. Okay, and so we know now that there's been a horizontal shift of 2, but there's been a vertical shift of 2 as well. So if we know those things, we can then begin to build up, if you like, the equation of the exponential. Well, here it is here. We know it must start with y equals a. A is some base we don't know. X, well, a at the base a to the power of x plus 2. Now don't forget the graph has gone 2 units in the negative x direction, so we have to have the opposite sign there to that. It's going to be plus 2. So it's going to be a to the power of x plus 2, and then because it's been shifted 2 units upwards, we write plus 2 on the end of our equation like that. Now we need to find the base. So if you look at the graph, you'll find that it goes through this point here. I've had to squash it in a little bit at the top of my sketch here, but you will find that if you go along on the original, you'll find that it goes through minus 1, 6. Okay, so if we use that point, which I have done here, we can use it to our advantage to find the base A. Well, 6 is our y value, minus 1 is our x value there, so we put that in there, and then we've got the plus 2 there. So we take the plus 2 first, over the equal sign goes to minus 2, so this left-hand side of the equal sign goes to 4. and minus 1 plus 2 is 1. So we found that a to the power of 1 is 4. So a must be 4. So the full equation for I, the curve I, is y equals 4 raised to the power of x plus 2 and then added to there at the end. Okay, let's move on to the next one, the exponential graph J. We again have the exponential doing something like this, and again we should note that there is an asymptote at y equals minus 2. And again, we imagine the original exponential doing something like that. And there's that very important point, 0, 1. Where has it gone to in the new exponential? Well, it's gone down by 2 units to there. Don't forget that new point there, which I'm pointing at, 0 minus 1. It has to be 1 unit above the new asymptote there. Okay, so there it's gone there. Now you'll notice it's only dropped 2 units. There has been no horizontal movement at all. So when we build up the equation, we're really saying that it is y equals the base a to x to the power, the base a to the power of x plus 0, because there's been no horizontal movement. But there has been a downward movement, vertically downward movement of minus 2 units, so that must go on the end. So our equation looks like this: y equals a to the power of x minus 2. And again, we look for a point on our new curve through which the graph goes nicely, and there, this one is there at 1, 1. You could have used any other point, but as long as it goes through the point nicely so that you can use it to find a. So I've used 1, 1, and when I do that, y is 1, the x is 1, and minus 2 there. So take the minus 2 across, goes to plus 2. So this is a to the power of 1 must be 3, which means that the final equation is y equals 3 to the power of x minus 2. Okay, now let's I've got to zoom out and go to the next page here. So I'm zooming out, going to my next page, and I'll zoom back into this one and keep going. All right, let's make it as big as we can. There we have it. All right, now which one was this? Oh yes, this is the exponential graph K. Well, K is doing something like this. And again, you should have zoomed in on the fact that there is an asymptote there at y equals 3. Okay, there's my original exponential. There's that all-important point, 0, 1. And where has it gone to? Well, it's gone to there. It's 1 unit above the asymptote, which is at 4, 1, which you can see quite easily on your graph in the workbook. Okay, so if it's gone 3 units up and it's gone 1 unit this way, well, we can begin then to use that to build up the equation. There it is. Y equals a, some base a, which we don't yet know, to the power of x minus 1, because it's gone 1 unit in the positive x direction. So we must use the opposite sign there and write minus 1. But it's gone 3 units vertically, so we have to write the plus 3 on the end. Now again, we look for a point on the graph, and there it is. I've used 3, 7. And if we do that, we can then begin to find a. And if I do that, there it is there. 7 is y, and 3 is my x there, so I put it into there. And 3 minus 1 is 2, so it's x squared, a squared. Take this plus 3 over the equal sign, goes to 7 minus 3, which is 4. So a squared is 4. So if we take the square root of 4, we get a is 2. Okay? So the full equation must be y equals 2 to the power of x minus 1, all plus 3. Now if we go on to the very last one, we can see that we've got a slightly different one here. Now, the very first thing you should see or should realize in this case is that this original exponential, which is going up like this, has been reflected in the x-axis, and there it is there in the blue dotted line there. It's been reflected in the x-axis. Now if it's been reflected, it means that we're going to have a minus sign in front of the base. Okay, and when you see this reflected one here, there it is, well, it's not in the right position for the one that we've got. We've got this one here. We've got an asymptote at y equals 1. Okay, it's going down like this, but it's this dotted one, it's been moved up 1. So this point here, there, the all-important point there, is reflected to there, and then it's shifted up by 1 unit. So the minus sign in front of the A does the reflection from there to there, and then the plus 1 on the end does the shift upwards like that. So the equation must begin something like this: y equals minus a to the power of x plus 1. And I used this point here, 2 minus 3, to find a. And when you do that, you can write that the minus 3 is the y value, and the x is 2. And we take this minus 1 across the equal sign, it goes to minus 1. And so we get minus 4 equals minus a squared. Well, if we multiply both sides by minus 1, they both turn positive. So it's the same thing. And also, if you divide both sides by minus 1, you will turn it into positive. So you get the 4 as a squared. So a, again, must be 2. So the full equation for this particular one is y equals minus 2 to the power of x plus 1. Okay, now there is one very important thing which I have overlooked at the moment, and that is, how do you describe the features and the domain and range of these equations? Now, I've got another page to show you when I've done this in detail for you. Now, I'm running out of time because I'm only allowed 15 minutes in a recording. So I'm going to have to end this one, and because I'm now on 14 minutes, and I'm going to make another one that is used solely to explain what we mean by the features of these graphs and the domain and range of these graphs. Because if you want full marks with these type of questions, you not only have to find equations of the new graphs, but you also have to describe the features of the graph and the domain and range, especially if you're trying to get, full marks. Okay, so I'll say goodbye to this one, and I'll get stuck into the next one because I'm just about to run out of time. Thank you.